Here's a review of trig function values in terms of the unit circle. So the unit circle is centered at 0, 0. It has radius of 1. If we have an angle, measure t with initial side on the positive x-axis and terminal side intersecting the unit circle at a point xy, we can then define the trig function values in terms of that point xy. So I have them listed here. The sine of that angle t is the y-coordinate of that point. The cosine of that angle t is the x-coordinate, and then tangent of that angle is y over x. So the sign, positive or negative, of the trig function value depends on where the terminal side of the angle is, which quadrant it is. If we start with quadrant 1, we look at an angle that has got terminal side in quadrant 1. Okay, so the terminal side intersects the unit circle at that point. Well, we know that both the x value and the y value are positive. Both are greater than 0. X and y determine those cosine and sine and tangent values. We are only going to have positive trig function values in quadrant 1. All right, let's look at quadrant 2. Angle with terminal side in quadrant 2 would be right there. All right, so let's think about x and y in that quadrant. Well, we are to the left of the origin, we're to the left of the y-axis, so that means x is going to be negative, less than 0. But y is still positive because those points are above the x-axis. In quadrant 2, sine is positive because y values are positive, cosine is negative because x values are negative, and tangent has one positive, one negative, so it is going to be negative. Quadrant 3. So this yellow angle has terminal side in quadrant 3. In quadrant 3, x values are negative, y values are also negative. So that tells us that the sine is going to be a negative value, cosine is a negative value, but since they're both negative, negative over a negative is going to mean tangent is a positive value. Now let's look at quadrant 4. So if we look at an angle with terminal side in quadrant 4, all right, we're going to have this angle right here going all the way around. X is positive in quadrant 4, y is negative. So we're going to have a sine value that is negative, cosine is positive, and then because one's positive, one's negative, tangent is negative. Now we're going to look at the quadrantial angles on the unit circle, and those are the angles that have their terminal side on the x or y axis, positive or negative x or y axis. So if we have terminal side on positive axis, positive x-axis, that's angle measure of 0, or if we have one full rotation, it's 2 pi. So the angle measure that corresponds to positive x-axis is 0 or 2 pi, or multiples of 2 pi. And the point that corresponds is 1, 0. If we have radius of 1, that means that it's going to be a distance of the origin to that point, which is 1. Now let's go 1/4 turn. That gives us angle measure of pi over 2. That corresponds to a point of x is 0 and y is 1. If we go 1/2 rotation, we get to pi, and that corresponding point, we're now in the negative direction for x, so it's -1 and a y is 0. We go 3/4 of a turn, we get 3 pi over 2, corresponds to the point x is 0, y is -1. Let's evaluate some trig functions for some given angles. Let's start with cosine of pi. So we're going to go to where we have our terminal side of pi. Now we know that cosine is going to be the x-coordinate of the corresponding point. So the x-coordinate is -1, so cosine of pi is just -1. All we have to do is just pick out that x-coordinate. So let's look at sine of 0. Okay, so terminal side of 0, we look at the point. Sine is going to be the y-coordinate, so we pick out the y-coordinate and we get that sine of 0 is equal to 0. Okay, now let's look at tangent of 2 pi. So 2 pi, terminal side is here. All right, we're going to reference this corresponding angle. So tangent is equal to y over x. The y-coordinate is 0, x-coordinate is 1, so we get 0 over 1 or 0. Secant of pi over 2. So let's remind ourselves of what secant is. Secant is the reciprocal function of cosine. So since cosine is x, secant is going to be equal to 1 over x. Here's the angle, pi over 2, the corresponding point. So we are going to use that to evaluate the secant. We're going to have 1 over the x-coordinate. Well, the x-coordinate is 0. Well, 0 in the denominator is undefined. So this trig function value does not exist. The secant of pi over 2 does not exist because we get 0 in the denominator. Okay, now let's look at this unit circle and the special angle pi over 4 and its multiples. So just a reminder, pi over 4 in degree measure is 45 degrees. In a previous video, we looked at 45 degrees and its multiples and corresponded it to multiples of pi over 4. We also determined the trig functions for this special angle. So those are given to us right here. So the sine of pi over 4 is square root 2 over 2. Cosine of pi over 4 is the same, square root 2 over 2. And then the tangent is this over this, so we get 1. So if we start in the first quadrant, pi over 4 is that angle that cuts that first quadrant in 2 equal pieces. So I'll label that as pi over 4. We want to identify the point that corresponds to that angle. All right, well, we can get that from our trig function values over here. All right, because cosine is the x-coordinate, that means the x-coordinate of this point is going to be the cosine, which is square root 2 over 2. And because y is the sine value, our y-coordinate is square root 2 over 2. Now let's look at the next multiple. We've got pi over 4, 2 pi over 4, but that's pi over 2, which we took care of in the previous slide. Here we have 3 pi over 4. So label that as 3 pi over 4. We want to write down the corresponding point. So the corresponding point is now going to be influenced by the sine and cosine value, but also the fact that the quadrant is, in this quadrant, x values are negative. So instead of being a positive square root 2 over 2, we're going to have a negative square root 2 over 2 because in this quadrant, x values are negative. And y values are positive, so that stays positive square root 2 over 2. All right, so I'll put that in there. Now let's look at the next one. To get to the next multiple, we have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is just pi, and then now 5 pi over 4. So label that 5 pi over 4, and now writing down the corresponding point. We're in the third quadrant, both x and y are negative, so we're going to have negative pi over 2, negative pi over 2 for the point. Next special angle, we have 1 pi over 4, 2, 3, 4, 5, 6, which corresponds to 3 pi over 2, and then finally 7 pi over 4 in the fourth quadrant. And writing down the corresponding point, we've got positive x, so positive square root 2 over 2. Y is negative, so negative square root 2 over 2. Now let's look at the unit circle and pi over 3 and its multiples, remembering that pi over 3 in degree measure is 60 degrees. We looked at the trig function values for this special angle, and we came up with those that are listed over here on the right. We're first going to just focus on 60 degrees. So we're going to focus on this column. And also just a reminder that the sine value we get from the y coordinate of the corresponding point to the terminal side on the unit circle. Cosine is x, and then tangent is y over x. So starting off in the first quadrant, pi over 3 has this terminal side, okay, going from the initial side on the positive x to that terminal side is 60 degrees, or pi over 3. And now let's write down the corresponding point. So we are going to first pick up the x-coordinate, which if we look at our chart over there is a positive 1/2. And the y-coordinate is the sine value, square root 3 over 2. Now let's look at the next multiple of 60 degrees, or pi over 3. So this was 1 pi over 3. Another pi over 3 gets us to this terminal side, and that is 2 pi over 3. Point that corresponds. So we're going to use the same values, 1/2 and square root 3 over 2. We just are going to put a negative in front of the x coordinate because it is x is negative in quadrant 2. So we get negative 1/2 square root 3 over 2 for that corresponding point. The next multiple of pi over 3, we have 1, 2, 3 is the same as pi, and now 4 pi over 3. Label the angle measure for pi over 3. And now the point, we're in the third quadrant, so both x and y are negative, so we're going to have negative 1/2 negative square root 3 over 2. Okay, going one more multiple, so 1, 2, 3, 4, 5 pi over 3. And the corresponding point, 1/2, because we are now in quadrant 4 where x is positive, but y is negative, so we have 1/2 negative square root 3 over 2. Now looking at the unit circle, in pi over 6 and its multiples, pi over 6 is in degree measure 30 degrees. Now because 30 degrees goes into 60, we've already covered some of its multiples. The ones where 30 goes into 60 evenly, those are going to be on the previous unit circle. But we're going to want to look at the ones that are just pi over 6 on its own. And we are going to focus on this column here because that's the pi over 6, that's the 30 degree column. And the reminder that sine is y values, cosine is x, and tangent is y over x. So the first angle in the first quadrant is here, and that's just pi over 6. Identifying the point, we can pick that up from the table. Cosine value is going to be the x value, so that's square root 3 over 2. And the y value is going to be the sine value, that's positive 1/2. The next multiple of pi over 6 that we're going to look at is the one in quadrant 2, and this is 5 pi over 6. If we want to count those out, here we have 1 pi over 6, 2 pi over 6, which is the same as pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, and then 5 pi over 6. Write down the point that corresponds. All right, so we pick up the x-coordinate from the cosine value, but this time it's negative because we're in this quadrant, negative square root 3 over 2. Y value is 1/2, that's the sine value. And so we get negative square root 3 over 2, 1/2. All right, the next multiple is 7 pi over 6. And the corresponding point is, again, negative square root 3 over 2. And now y is negative, so we have negative 1/2. And the last multiple that we're going to look at is here, and this is 11 pi over 6, corresponding to the point square root 3 over 2, 1/2.